What we're going to do today is just practice a few more domain and range questions, kind of phrased differently. This was a do now I had the kids do in class a while back. The first one says, find a function which has the following domains. We're kind of going backwards. I'm giving you the domain first, and I want to know what equation it came from. And there's a couple of hints. First off, see the solid bracket? That means it is not in the denominator. Anytime things have soft brackets, we know it's in the denominator because you can't have zeros in the denominator. So the fact that it's a solid bracket here means everything's going to be occurring in the numerator. The other thing you're going to notice is that it's an interval. So what I used to tell the guys was draw a number line. Right? It's a 2 with a solid dot. So this is what the picture would look like. So anytime you have an arrow going in one direction only, this is a huge hint. It's a radical equation. So I'm going to write y equals radical, right? And what would I put in here so that if you plugged in the number 2, it would make a 0? And that would be x minus 2. And what we can do now is check to see if this works. Right? If I plug 2 in, 2 minus 2 is 0. Now, if I plug 3 in, see how there's no arrow? It means it shouldn't work. But what happens if I plug a 3 in here? It does work. That means this is written backwards. So I'm going to change it to y equals radical 2 minus x. Now if I plug in 3, it doesn't work. But if I plug in 0, for example, it does. So sometimes your first guess isn't necessarily correct. You may have to go back and check yourself. So let's try this again now. Here's another one. Notice they're all soft brackets. That's a huge hint that it's going to be a fraction. And I'm going to draw the number line here. So when I draw this number line, we have a -1, right, and a 3. So if you notice all soft brackets, it means we're not using -1 and we're not using 3. But we're using down from here, okay, between -1 and 3. Okay. So this is what this would look like as a graph. Now, I want to compare these two. If you notice, in this number line, see how a section of it is missing? That's a huge hint. It's also a radical when there's a piece missing. Notice here, everything is shaded except for these two locations. That means when we go to write the equation now, for example, f of x equals. You can put any number you want to, like 5, 1, you can put anything up there. But down in here, it's going to be 1, 2 parentheses, 1 for each number. But not in a radical, because if there was a radical involved, there'd be a section missing. So see here how it's a -1? That means that came out of x plus 1. And see how that's a positive 3? It would be x minus 3. Because if you plug 3 in there, it would make a 0. And if I plug -1 in there, it would make that 0. So this is the answer. Okay. So let's take a look at the next one. Okay. Notice it's soft brackets. If I look at this, I'm making a -4, which we're not using because it's a soft bracket. But we're going towards positive infinity. Now there's two tells in this. The fact that it's a soft bracket means it's going to be in the denominator because we can't have a 0 in the denominator. The other issue is this blank section. So when I go to write this equation, and notice I have y equals f of x equals, you have to, for it to be an equation or a function, you need to have it equal to something. So that means we're going to have a fraction. This time, because there's a section missing, means there's a radical in the denominator. And then my first guess would be to do x plus 4, right? Because if I plug -4 in there, it would make it 0. Now I'm going to test it with the interval. Pick a number bigger than -4, like -3. Would that work in there? Yes, it would, right? What about a number smaller than -4? -5. Nope. So that means we got it right. All right, see if you can handle that next one now. Either pause me or see if you can do that one. Okay. So I'm hoping you did. Hopefully you paused me. You drew your number line. We have a -4, which we're allowed to have because it's a solid bracket. A +4. Okay. We're going down, and we're going up. All right, so 2 important things. Lack of soft brackets means it's going to be in the numerator, so it won't be a fraction. And the fact that there's a missing section in here means it's a radical. So what if I do g of x? Right, it's going to be a radical. Now, see how it's 2 versions of the 4, a +4 and a -4? That means it's going to be an x squared. And what happens when you square 4? What number would you get? Okay. So it's either going to be this guy or this guy. And the way you can check is by testing. Look, 0 shouldn't work, right? So if I plug in 0 here, does it work? Nope. So that's why that one is correct and this one isn't. So it's going to be that one. Boom. All right, so that's how you would do it working backwards. Now what I would like you to do is pause me and see if you can do these bottom few. And then turn me back on. Okay, let's see how you did. All right, I got to find the domain for these, right? So the first thing you should have done here is factored, right? X minus 5. What would make that 0 and that 0? So I draw my number line. That would be 0 and +5. Because it's in the denominator, I cannot have those, right? But it's not a radical, so that means everything else would work. So the domain for this one would be -infinity to the 0, or 0 to 5, or 5 and up. Notice there's 1, 2, 3 shaded areas, and I have 1, 2, 3 intervals. All right, letter B. Okay, that's unfactorable. So that makes this easy. That means nothing will ruin it, so the domain is all real numbers. Okay. This guy. Now, if you can't figure out off the top of your head what would make that 0, just set it equal to 0. Look, I want to know what would make that equal to 0. Add over the 8. Right? Take the square root of that. Now, remember, when you take the square root, it's plus minus radical 8. And anytime it's a radical, you really should break those up. So it's going to be 2 radical 2. I'm going to make my number line. So I got -2 radical 2 and +2 radical 2. All right, now I'm going to test. Now, since it's not a fraction, we can keep those. All right, radical 2 is about 1.4. So if you times it by 2, was it 2.8? So just pick a number bigger than that, like 5. Plug 5 in there. Will it work? Sure. Okay. Plug 0 won't work, right? And -5 would work. So this domain would be -infinity to -2 radical 2 solid bracket, or solid bracket 2 radical 2 to infinity. All right, this is the first time you've seen one of these. Now, this is what we call dueling radicals. When you've got a radical in the numerator and in the denominator, you actually have to make 2 different number lines. You've got to make a number line for the numerator and for the denominator. So I'm going to do one up here and one down here. And you have to line them up perfectly. Now, what numbers would make this guy 0? I'm hoping you're thinking -5 and 5, right? And this could be solid dots. So I'm doing just the numerator. I'm totally ignoring the denominator here. So now I'm going to test. If I plug in 6, 6 would be no good, right? 0 would work, right? And -6 would be no good. So this is just for the numerator. Now I'm going to do it and ignore the numerator and just do the denominator. Okay? Now, what would make this 0? -3. Now, -3 I'm going to put where it would be here. It's about there. Okay? Now, because it's in the denominator, though, we can't have -3. Now, can I have -4? No. Can I have 0? Yes. So this one would be like that. Now here's why you had to write 2 radicals. The answer is from here to here, from -3 to 5. But notice at -3 I have an x. So when you go to do the domain, it's soft bracket -3 to hard bracket 5. So that's a little tricky. Right, we're going to do more of those. All right, and I want to run through now. You need to find the domain and the range for these. So I think you might be able to do the first 2. So you could pause me, give those a try. And then I'll run through them. Okay, so I hope you pause me. When you look at this, I'm hoping you're thinking it's not a fraction nor a radical. So the domain is all real numbers, which you write as -infinity to +infinity, right? And when you do range now, you want to think about what it looks like when you graph it. 5x minus 1 would be a line, right? A diagonal line, something like that. So the domain is all real numbers, and so is the range. Okay, number 2. Let's do the domain first. Okay, what number would ruin that? Right, a 4. It's in the numerator, right? It's not a fraction, so we have a solid dot. And then we're going to test 5 works, but 3 does not. Right, so the domain is solid bracket 4 and up. Now, for trickier ones, use your domain to find the range, right? Make an XY chart. We're going to start at 4 and get bigger, right? If I plug in 4, I get radical 0, which is 0. If I plug in 5, I get radical 1, which is 1, right? Plug in 6, radical 2, right? You can jump. You don't have to go in order. What if you jump to 10, right? That'd make radical 6. And if we plug in 100, that'd be radical 96. What's happening to those radicals? Right? They keep getting bigger. So the smallest number I'd ever have is 0, but I can go up forever. Okay. Now, another way of thinking about this, I'm going to kind of put it up in the corner. This 10 is... Okay. If I were to graph y equals radical x, it's going to look like this. That's what radical graphs typically look like. Now, if I take a look at this guy, right, if we plotted these points here, it would be over 4 up 0, and it would look like this. Okay? Check out this one and this. Notice it's a shift 4 to the right, so you can actually bring in your shifting ideas to help us out on these. All right, so let's try number 3 now. What do you think the domain and range is for that one? And you are correct. It's not a radical, it's not a fraction, so it's going to be all real numbers. So now let's talk about the range. Now, you could plug in numbers, or let's think about what the graph would look like. What do absolute value graphs look like? And I hope you remember that when you graph the absolute value, it's a V that hits the origin like that, right? This would also be a V, but it's going to be shifted. Where would this guy be shifted to? And I hope you remember that anytime it affects the x, we do the opposite. So remember here, it was x minus 4, but it moved 4 to the right. Well, this one would be a V shifted to the left, -8. So if you can graph the picture, sometimes that helps you get the range. Range is how low to how high? Well, the lowest we're going down to is 0, but we're going up forever. All right, so the next one. What would my domain be for that one? Okay, correct. I hope you're thinking all real numbers, right? Because it's not a fraction or a radical. What would be the parent function, since you saw the other lessons on parent functions? This would be a parabola, right? If I were to graph y equals x squared, that would be the parent function of this guy. It would be a parabola that hits the origin. But those other numbers move it. How would those other numbers move this equation? Well, we would move it left 2, down 5. So that means I'd go back 2, down 5. I'm going to cheat a little and just do that. So if that's the picture now I know the range is how low do we go? -5 up to infinity. All right, one more. Take a second. See if you can get that domain at least. Start with the domain. So what would ruin it? Right? -5 and 5. We can have them because it's not a fraction. Test 6 will not work. 0 will. -6 will work. So the domain for this one is going to be between -5 and 5. Now, just like number 2, this one might be easier to do an XY chart with. Let's talk about what we get. Now, because it's a very specific interval, it's not going to infinity, I like to test all of those numbers to see what's going on. So I'm going to go, looks like I'm going to run the room, all the way from -5 to 5. So plug -5 in that, you get 0. Plug -4 in there, right? That would be 16. What's 25 minus 16? 9, square root of 9 is 3, right? Plug 3 in there. 25 minus 9 is radical 16, which is 4. Plug 2 in there, and it's radical 21. Right? Then we get radical 24. Plug 0 in, you get radical 25 is 5. And then if you do this, it's just going to repeat going back. And then we end up with, what is this, 4, 3, 0. So if you were to graph this at -5 at 0, at -4 at 1, 2, 3, at -3, 1, 2, 3, 4, it'd be here. At 0, it's 5, and I'm just going to make a sketch here. Look at that. So my range is from 0 to 5. That's a semicircle. That's an equation of a semicircle. So you can use, for the trickier ones, just use the XY chart to figure out what the range would be. And for basic equations, you want to shift them, and that makes life easier. All right, kiddo, got some more assignments for you to try. See you soon.